Simplify the following, leaving your answer with a positive indices. Isn't it great to have such a positive question? Not really, because that makes our life a bit harder, but oh well, here we are. So just looking at the first question, is that simplified? And does it have positive indices? So is it simplified? Quite simple. Well, maybe to me, maybe not to you, I don't know. So it could be simplified, but does it have a positive indices? No. Right, we have to the power of -2. So our first step for this one is to try and rewrite that with a positive indice, and then we can go about simplifying it. So we need to use our power rules to do that. And the power rule we'll use is this. So if we have a number, let's just say 2, and we raise it to the power of -3, for example, we could work that out on our calculator, right? That's just a number. So we do run maths 2 hat, so above ln or left of exit, -3, which gives us 0.125, or as a fraction, 1/8. And the power rule says that this is equal to 1 over 2 to the power of +3. So notice the 2 stays the same, the 3 stays the same, except I changed the sign. In this case, I went from negative to positive. And sure enough, if we check, 1 divided by 2 hat cubed gives us 0.125, or 1/8. So using this rule, this power rule, called like the negative power rule, we can rewrite 4x to the -2 as 1 over 4x squared. Now right here, I did make a mistake on purpose. Have a guess at what that is, other than leaving out the 3. We'll get to that in a second. So the 4x is in brackets, which means this whole 4 times x is raised to the -2. So when we use the negative power rule, we need to be careful in that we're raising 4x all to the power of +2, right? But here it's in the denominator now. Great, and now the 3, well, that's just 3 times this whole expression, which we said is now this. So you could write it like this, 3 times all that, or we could just put the 3 in the numerator, because 3 times 1 is 3. So this is using negative power rule. And what we've done here is we've replaced the negative indices with a positive one. And now let's try simplify. So the 3, can't really simplify that, but 4x all squared, we could distribute the squared, the power of 2, across each term. So that becomes 4 to the power of 2 times x to the power of 2. Right, and that's why those brackets were so important, because we would have missed this step if we left them off. That becomes 3 over 4 squared, which is 16, and x squared is x squared. And now we just check, does 16 go into 3? No. Okay, so we can't simplify that anymore. So that is our final answer. Alright, now part 2, again, leaving our answer with positive indices, simplifying this one. Let's go with the BEDMAS approach, where we focus in on trying to simplify the thing within the brackets. This isn't the only way, but it's a good first approach. So looking inside the brackets, 16 divided by 1, right? There's a hidden 1 there, so we can't simplify that. X to the power of 4 divided by x to the power of 6. So we can use a power rule for that. But let's just have a think. X to the power of 4 is x times itself 4 times. X to the power of 6, x times itself 6 times. And if we were to simplify this, x divided by x is 1, x divided by x is 1, 1, 1, and we're left with 1 over x times x, or 1 over x squared. So, going back to this problem, x to the power of 4 divided by x to the power of 6 equals 1 over x squared. Now, if you want to use a power rule instead of thinking about it like this, the power rule is when we divide powers, so x to the power of 4 divided by x to the power of 6, it becomes, so x, the same base, to the power of the numerator's power minus the power of the denominator's power. In other words, 4 minus 6, which gives us x to the power of negative 2. And remember, this problem actually wants us to leave our answer with positive indices, so we'd use the same negative power rule as in question 1 to convert it to 1 over x squared. So either method works, they are exactly equivalent. This uses the power rule to get x to the negative 2, and then the negative power rule to get 1 over x squared, whereas the first line is just reasoning about how the x's will cancel out. Alright, now that is to say that this expression becomes 16 over x squared, right? Because the x is simplified to 1 over x squared, the 16 stays the same, and that's all to the power of 3 over 2. Alright, I'll just clear this out. Now let's have a think what's going to happen next. So this power of 3 over 2, we can distribute that across each term, which gives us 16 to the power of 3 over 2 divided by x squared, all to the power of 3 over 2. So we distributed the power because we were dividing in the bracket. We'd also distribute it if we're multiplying, but that was like in this question up here with the 4x squared. Right, that was multiplying. Here it's dividing. We still need to raise each term to the power. And now if you're stuck on simplifying these ones, you can use your calculator. 16 to the power of, use brackets here, 3 divided by 2 gives us 64. All divided by, now it's a bit harder to use our calculator here because x is an unknown. So if we have a power of a power, we multiply the powers. So that's x to the power of 2 times 3 over 2. Now 2 times 3 over 2, 2 divided by 2 is 1, and we're left with 3. So 64 over x cubed. Great. Now if you're wondering, just back to this step, how we go from there to there without our calculator, when we raise something to the power of a half, that's the same as saying we square root it. So the square root of 16 is 4, and then we're raising it to the power of 3. So 4 cubed is 4 times 4 times 4, which is 64. Right, so that's just different notation. But here, calculator is totally fine.